In your practical exercise, you have to implement stream-oriented editor which reads or writes either from standard input, output, and from file to file with simple replacements. So, description of this editor is given here in to do, but demonstration is better than written description, so I will demonstrate it. And before we start demonstrating, you should know that there are two different kind of editors. How can you edit text? Okay, let's call one called full text editor and another stream editor. Full text editor is usually used by real humans, by users. What it does, it reads everything inside virtual memory. Of course, if this everything is many megabytes of data, it may be paged, so it reads some page of entire document. But if it's not many megabytes or gigabytes, it reads full text into memory, and then you can navigate through this, because usually you do not see everything in your screen, but you can easily navigate it. So this means part of this text may be before your screen, part of text after your screen, and you can insert new lines here, you can delete some lines here, you can easily navigate using different navigation possibilities to do different kind of operations. So good thing about such full text editors is that you can modify this text in any place you like, because it allows you to navigate using different navigation approaches from the beginning till to the end of this file. But stream editors are completely different ones. They remember usually only one line of the text in this stream, so there may be megabytes or gigabytes of data before that or after that, but they do not try to read everything inside virtual memory. They try to read only one current line in memory, and more complicated ones remember stack of structure. For example, if you have XML file, which is also text file, which has elements inside elements inside elements, or you have some other structure like you have Markdown text, where you have some bold marks inside paragraph, etc. Some of more advanced stream editors may remember this structure, that this is now under this particular header, under this particular paragraph, under blah blah blah. So if you have some text element inside text element inside text element, they may remember something about this structural part. But if they are very simple, they don't even remember that. Only thing they remember is current line. And where these ones are used, of course, in most of cases these are not used by real human. But 50 years ago, there was editor called Ed, which was actually something like a stream-oriented editor, where you only dealt with one particular line of large files. Why? Because these are intended for these terminals which used paper as an output. And for example, you do not want to refresh your so-called paper screen and print many hundreds of lines of text for each small modification you do inside your file, because then you will waste quite a lot of paper just to print something out. So it printed out particular line which you could add, replace, whatever. But such stream editors are still very useful and widely used when you have large stream of data, in this case text-oriented data, when you need to filter out something or add something after some markers. So you read many lines, blah 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 blah. When you get some condition, when you need to change something, you change something and you continue. And in GNU utilities, very important tool you should know how to use is stream editor called sed, where it called stream editor. So, and it uses regular expressions. We talked about these already in previous week. Because remember, everything which can be implemented with this stack automator or pushdown automator, you remember something into stack may be described as a regular language, and if may be described as a regular language, then you can do whatever you like to remembering something into stack. And so this stream editor or sed is used very widely in many different applications. And your exercise also will be to implement very simple stream editor which reads many lines of data from text-oriented streams, either standard input, output or files. It remembers only current line and it remembers number of lines read or read it if you use regular English. And then it may replace this particular line to something else. And how does it work? If we look on already implemented editor and we run it without any arguments, it prints out following output in standard error output. How do we know that it's standard error output? Because if we redirect second stream into the null device, it doesn't print anything. And also it changes so-called return status. Return status, either here or in set command, there is one of variable which may be used to check what was condition of previously executed command. I don't know where exactly you can look at it in set of all environment variables, but you can get it out by referring to it with $? In Unix-like systems. I don't know about VMS and Microsoft Windows. And for example, if this previous command was successful, it is 0. If it's unsuccessful, like ls something which doesn't exist, then it is non-zero. There is no good standard what this non-zero is, but what is standardized is that success means 0 for this return status. And this stream editor also returns this status. For example, if you call it without parameters and check what return status is, this return status is set to the 1, which is considered failure, not success. And then if you actually run it successfully, you have to pass 1, 2, 3, 4 parameters to it. And first is line to be replaced. then read either then text to other place, let's say 3, and then read either from standard input dash or name of file and standard output dash or name of file. And if we call it in following way, then it reads from standard input, writes to standard output, and replaces second read line to the AAA. And I provide 3 lines as an input, and you may think, oh, it doesn't look like a stream editor, because here I provided quite a lot of input, nothing was written out yet. Remember that you have to use buffering to deal with latencies, otherwise it will be very, very slow. And this editor uses buffered reading and buffered writing, and it will not produce anything in output until this buffer will be full. And so to make buffer full, my input should be a few kilobytes in length. I will not try to do this, but I will just say end of stream, pressing Ctrl D, and now it provided this output. First line without changes, second line replaced, and third line without changes. If I say that output should be output.txt, and I provide input from standard input, then it creates file out.txt with the same output. And of course, if you use redirection, I could do the same result, saying read from standard input, write from standard output, but redirect it to the file out.txt. So result is still the same, even though details are quite different. So, and if I have following file and I say read from file in txt, provide output into standard output, I see following output. If I say write it into file called out.txt, oops, too many parameters, and I see it in output. And again, I could do this in a little bit different way, saying read from standard input, write to standard output, but redirect input from int.txt and redirect output to out.txt. It will work in absolutely the same way. So, then it may drop one particular line. For example, saying that this is negative number. Then this mentioned line is not replaced, then this parameter or argument is ignored, and it prints out only first and third line. And then if you say that some 10th line should be replaced, it needs to pad with empty lines here to be able to replace 10th line which doesn't exist in its input. No idea, there are no requirements what should happen if 10 lines should be deleted. Nothing has changed. So there is nothing to be dropped because there are not so many lines to be dropped or removed. And I think that's it about behavior of this stream editor. So now about code itself. Design is already given for us for the stream editor. We just need to follow for these to-dos and implement them. And we will complete this to do one by one, starting with easiest one. So first to do, probably the easiest one, is just to check how many arguments were passed inside this string of arguments. And if these arguments are not 4, then print messaging error stream and return execution status to 1. So we need to check if args. Let's double check what I have in auto. So if your Eclipse provides you some wrong suggestions for auto completion, then here you can customize it in Java Editor, Content Assistant, Advanced Proposals. And what I find out that, at least for me, it should always start with Java related proposals first. Java, Java type, maybe Java non-type, where is also Java. And maybe these ones. Otherwise, this auto-completion provides me something else. So Eclipse, as usual, it is very configurable. But you can misconfigure it. So what I want to get is that for auto-completion, it may shows usually these things, not something else. So if args length is not 4, I think, then first we need to print something in standard error output, which is system error object, print line, and here line break will be added automatically depending on what kind of operating system I have, as a line feed for Unix-like systems or line feed carriage return for Windows and VMS-like system. And we need to print out following message. And we need to return non-zero system exit status with this command. And with that, I think, of course it's not tested, but I think this is done. Then we will start analyzing and remembering values for these passed arguments from these command line parameters. So and here this design suggests for us that instead of cells inside this array, we will introduce some other local variables, because it's much easier to remember and easier to understand. Remember when I told you about inner classes, for example, in object-oriented approach you should always have proper structure of data or properly named variables to make your code easier to understand, easier to debug and maintain. So instead of referring to these cells of arrays all the time where we can make mistake, we will do something like this, that line number which needs to be changed is more user-friendly named, and it is args zeros parameter, but of course we need to, this is string, even though it will contain only numbers, but we need to create it to proper number, like integer, and we parse it. But then we need to remember that if we pass negative number here or dash and digits, we actually need to delete that line, not to replace with something. And if this line number, still my auto completion is not great. So if it is negative number, what do? First we need to remember that this line should be actually deleted. And second, then we need to change it to positive number. And what can you do about this? You can do following. Either you rely to math from this. If you do not like to rely on this, you can multiply it by -1. In this particular case, I will leave it in following way. And handling for this first argument, I think, is done. Then text to replace. So text to replace is also somewhere given to us, string, which need to be put in line. I think we can use this variable declared here. And because this is string, that is string, I think that's it. Then we need to handle these parameters either reading from standard input output or from file to file. And we don't need to remember this dash or name of file, but we need to remember that if it's dash, we read from standard input. If it's non-dash, then we read from this file. So, and we do something like this. And so what is idea here? If we need to remember this for later, we assign more programmer-friendly named variables for them and convert as here or if necessary. If we don't need to remember, then of course we just say if args, which will be I think second cell. So if it's dash, and remember here, you always start with comparing with literal value, because literal value will be initialized for you, so it will never be null. And if this parameter will be null for some reason, it will not be true, and you will not get some problems with null pointer exceptions. If you try to do in opposite way, you have to write something like this: args second is not null, and here of course it should be the shortcut and, because if it's null, nothing should be compared here after that, and then you do args equals this string. because if it will be null, then you will not be able to call dot equals method for this null, because here in this case we are checking that all needed parameters are passed. It shouldn't be null, but to be safe, remember that when you need to compare to literal value, starting with literal value is always better and shorter code, because in this case I don't need to check if this is not null. So if this is following, we need to read from standard input. And because I never bother to remember details for this, usually I just Google it, but in this particular case, in your project, of course, you go to presentations in your project IO and look for examples, reading from standard input. It is like this. We create buffered reader, and only difference is that design here is already given to us, so our buffered reader is called reader. So we do not create some local variable here, we reuse that and we create buffered reader, which uses input stream reader to refer particularly to system in object and system in object. I think we don't need to do anything else. It means we don't need brackets here. Else we need to read from file. And reading from file, also Google it or look on some examples, read from file. So we need something like this. And because I don't need the reference to file exactly, because I will not do anything else with this, I can do something like this. And this is not args from, it is number 2. Here, some to do is still left. But maybe we can do everything together. So we need to check does it file exists. Then that means we have to have file. Do we have file object here? We have in file. And remember that when I use this constructor new file, I'm not actually creating file in my file system, in operating system in my disk. What I'm creating here, I'm creating this management object through which I will be able to manage things inside my file system. So new file doesn't mean that I create new file, it means I create so-called file handler to handle this file through the Java. And it may happen that such file doesn't exist, and therefore we need to check does it exist or not. If in file exists, but we need in opposite way, doesn't exist, then create it. And then we assign buffered file reader to this file. So that's about handling this particular argument. Now we need to handle last argument in similar fashion. And this will be cell number 3 for this array. And then we need to write the standard output. Where can we see how to write the standard output? Read, write to file. One example looks like missing. Write to standard output. Then we Google it. Doesn't look a good example for me. This looks good to me. What I mean good or bad, I want to get some kind of writer. And again, design is already given to us. We have print writer, and you see the same type, print writer. And when I was looking on this here, Java helps a lot that it's strongly typed language. I needed example when I assign it to print writer object. Something in between here, I don't care so much about them, but here there should be system.out object. And because this is precise type, what I need, system.out, and this is precise type print writer, then there is not much of options what particular constructor I need here to get this from this to that. So, then I'm maybe curious, and you may be curious, why do we need second argument here for this method? And here we see that second argument is boolean auto flush. Flush means flush your buffer, because we will manage flushing by ourselves to make it faster. Because auto flush in print writer, I think it will flush buffer for each line, printed line, and it is too frequently. We should flush buffer only when it's full, like few kilobytes in size. And something is bad with my brackets here. And then else we need to write into file, and writing to the file was given as an example here. We have some additional lines of code here, but we will deal with that. So we need writer here, new print writer, new file writer, new file object, with args3 here. That's interesting. So some import is missing here. Usually all needed imports are there. But looks like it's compiling and hopefully it will even work. So you see here that this part is the same, even though in one case we are writing in output, in another case in file. But this is our common factor, and similarly here, reader is the same. We create buffered reader, but in one case we do it for system input and in another case in file and handler of the file. And it is not tested, but it is compiling, and when we will test it, hopefully it will work. And I think this to-do is also actually completed because we did what is required here to create file if it doesn't exist. Particularly for writer, we don't need to create file first, because for writer, if file doesn't exist, it is created automatically. But for reader, somebody writes in chat buffered writer. It's good comment. I think yes, if there is a needed import here for a buffered writer, and this is my auto prompt, then it could be. There is difference. In print writer we use a string-oriented approach and we don't care about line breaks so much because we will just use println. But for only buffered writer, we have only a write method. So where is difference? If you call write method, which is supported by buffered writer, you write bytes here. And of course you can override and you can always pass string here instead of array of bytes. But then you need to remember about line breaks. And line breaks are platform dependent. But if you use, so that would be writer, buffered writer. But if we use print writer, it also has write method inherited from buffered writer, but it also has println method. And then you just can pass string here and line break will be added automatic. And if you want to go in details, for example, where is our print writer? And Java documentation. You see that it extends just a Java writer and here you have only write methods. And particularly for buffered writer, you have buffered write methods, but print writer has println method. And I think that in this particular case, when we have to deal with simple strings, not with some binary data, etc., we will not use write method, which is more general, but then we need to care with line breaks by ourselves. But we will use println, which is more handy. So that's about here about these writers. Now we actually need to start implementing this reading-writing business. And again, I will start with some example. Which example could be better for me? I think this loop looks like better starting point for me. And of course we need to refactor this example because current string is probably this variable. In is actually reader in our case. And then, instead of just writing into system.out directly, we actually need to write it into file. Which is something like this. And out, of course, is writer for us, and this is something like this. And then we need to remember that all these are buffered readers and writers, and we need to flush our buffers. If we are very ceremonial, we may try to check about reader buffering, flushing, but definitely we need to flush writer. Flush, and then reader, close, writer, close. Remember why this closing of files is important. If you will not close, for readers it's not important because it's read only, but if you will not close writers and you will be run it on stupid operating system which doesn't check that locked files are locked by non-running processes, then this file will not be writable to any other process until this system will be rebooted. I think that modern Windows are not so stupid that they check that there is no running process who has made lock on this file for writing anymore, but it's a good thing to do to not abuse and test operating system for its robustness to close these streams of data. And with that, we may try to test it, and for me, I think it's much easier. For example, if you want to test in Eclipse, you run it at least once to create default run configuration, and then you customize created run configuration here by passing arguments. But then when I need to change them, I need to do many clicks, and I don't like to do this. Therefore, for me it's easier following. So for me it's much easier to test it here in terminal. And first let's try to test it from standard input to standard output. And it even works. Of course, replacement doesn't work. It even reads. So in general, reading writing part is working. So next we can do some kind of optimization here. For example, you may see that you can do everything here together instead of two different lines. Something like this. I think there was some examples which use this shorter, more complicated. It should be put in brackets first. So sometimes to make it shorter, this introduction part of line can be put here. Why? Because if you do this first as a separate read line operation outside cycle, then you also need to add another line of code here, read line again. So when we did this calculation of order set elements, we dealt with this going into loop, inside loop, maybe going out of the loop. And here we have some duplicated conditions here, or operations, reader read line before loop, and then reader read line inside the loop. But sometimes you may do it everything inside this while. This means while execute reader read line, and while this result is not null. So here I had one line before that and one line inside body. Now this line became a little bit larger, but I get rid of this introduction part of line and this line here in the body. So it's up to you how do you decide it. But these who want to make code as short as possible may be using this approach. First, read this line, assign to this variable, and if it's not null, so there was something read from this file, continue, in this case print it out. So that is a little bit of optimization again. And now about this business of replacement, what we need to do. First we need to count how many lines were read, and I think that here also we have content for current line number. We can incremented by 1. And then if this current line number is passed line number, which variable is which one? This in line no. Then here we have two options. If delete, so delete means just not printing it out. So we just do not if delete continue, else we replace with what we need to replace, and for that we have remembered it in variable like this content. And now something should be even working with these replacements, but it looks like it is working a little bit incorrectly, because it should replace first line. So it replaced, but first line still was printed out. Else should be in this level. Okay, we'll do it. Not in this, but in. So we reach this line, if delete, continue, why it was printing it out. And we replace and continue again, that was my problem. Because then we don't need to write actually current line. So, particularly for Linux, formatting rules where leading programming language of course is C, not Java, but Java has inherited syntax from C, is that they say if you have if and else conditions, and for one of these conditions you have brackets, then you should add brackets also here for symmetry. That would be for Linux kernel formatting rules. I still am constructively lazy and I do not follow these standards so well. Of course, sometimes I make mistakes, I add some line and it's not executed, but because I rely on auto formatting, usually this is not so big problem for me. Oh. Something is wrong with my brackets here. And looks like it is working now. Let's replace last line. Yeah. So that's about this replacement. And we may consider this done, but here is note, up and break to the end of line, only if it's not null or empty string, and I will tell about this in details later. Now about this padding. So if we need to replace line which number is much bigger than there was actually passed lines, if we need to delete we don't do anything, but if we need to replace we need to pad it. So here we need to check if counted line numbers, and here remember that I count lines before checking them, because usually when you talk about lines you do not use their zero indexed in your text. For example, if you have one line in your document, then it's your first line, not zeroth line. So I increment this line number before I do all the checks, so it's one indexed, not zero indexed. And if this current line is smaller than line which needs to be replaced, then we need to pad it. And the question is how many things we need to pad. I don't know, but I will not calculate it myself because I'm bad at arithmetics. Not if 4. But I will say to computer to do for me. So this will be starting with current line number. E should be, I do not know, either smaller than equal than this line which should be replaced. And so here, with this starting condition that instead of 0 I have this one, and end condition is this one, it will do it as many times as there is difference between this and that, plus minus 1. Because usually when I write loops, my precision is plus minus 1. And then we will test it out, either we will need to add equals here or whatever. And so we pad it with empty lines. This means we print line, which is empty line. And then when it is done, we actually print line which should be replaced to. Something like this. And because I'm never sure about my cycles and loops, it needs to be tested. So let's replace second line, provide only one line. Looks like it is working quite nicely. But this doesn't look nicely. 1, 2, 3. It replaced fourth line. I think we need to take -1 here, -1 here. And because this is one index set, we shouldn't get negative number here. So replace something. Check it out what is wrong here. I actually print out too much things. 1, 2, 3. That was already. Now it's not printed out. Maybe only here. Looks like and here, as you see, my approach is like for tester. Instead of trying to understand my code, I just check its behavior. And as far as I tell, with precision, plus minus something, even this part is working. And now, when it's somehow working, we may be brave and we may try to run JUnit test, and JUnit test now is again in proper place in tests folder, not in mine folder. And JUnit test doesn't pass. And that means something is not completely correct with our editing. Does it always does the same? Oh, I have no good idea what is exactly wrong there. Maybe something with replacement. Yeah. Deletion actually doesn't work. Yeah, so something is logic error for me. And why? But if it continues, this shouldn't be happening. Let's be sure that everything is good with our brackets here. So that is one problem here. We reached this. We just continue with next iteration. Okay, if we cannot understand it by ourselves in mind, so we need to emulate deletion of something from standard input to standard output. Not stream editor test, sorry. But for run configuration for this, run configurations, not for test, but for Java application, for this configuration. then we need somewhere some breakpoint. And what we will do for debugging purposes, we will flush write buffer immediately to see which particular line is printed out immediately. You shouldn't leave such things later for production purposes. Oh, it's 0. Should be 2. So I have problem somewhere here. This is -2. But this is 0. That's strange. Oh, here it is, -2. Oh, yeah. That's what happens when you do auto-completion, which you do not regulate properly. Okay, so then maybe this logic is even properly implemented. So let's run it. Ah, it even works. That's great. So now about this comment here. And I think that for reference implementation it is used this more general buffered writer instead of print writer. But then this code should be, but I will show you where this problem may happen. And then difference is following that why it doesn't take. But here writer log. File, yeah, I know this, that is compiling for me. Output stream writer in between, probably. And where is difference? We do not have print line for buffered writer, but we have write. And then we need to add line breaks by ourselves. And how we'll do it? This character. Or you can do it as a string as well. And as soon, and here of course I make it platform dependent, I'm sloppy programmer. And here as well. Oops, and as soon as I start adding line breaks by myself, one of problem which may happen is that, still works, okay, then I will just mention. So when you do your own text editing, you should always add line breaks only at the end of non-empty lines. For example, in many cases you can do different kind of bulk operations. For example, here concatenate or just cut content of files in standard output using this pattern, anything.txt. And if I have nicely formatted files, I see content of all these files put nicely together. But if I have, for example, pay attention here that I'm using echo command. -9 means do not add line break at the end of AAA, because for example nice text editors like V or VI or Vim or Gwim actually do not allow you to create such broken file which has content and not nice line break at the end of file. And now when I concatenate them, I see that there is merged content together because it has missing line break at this file. And for example, if you have empty line here, your content is even more garbled. So missing line break here, unneeded line break here, and what you initially had here as very nicely joined text together from different files, now it has garbled content. And therefore every time you do your own some kind of editors, producing streams, etc., you should remember that nicely formatted text files or text streams are following, that if you have non-empty content of this line, you should add line break at the end, and of course if you do it platform independent, you add proper line break for each particular platform. And if you have empty line, there you shouldn't have these line breaks if this line actually doesn't need to be empty. And so that's what is this comment about these line breaks, that if you do like buffered writer instead of print writer and use write command instead of println command, you need to be careful that you have line breaks added only where they are needed. And of course, if you want to make it platform independent, then you need to do something like that. You check what is system line separator first, something like a chart. Oh, it's string. And instead of that, you use something like this. And it still works, but I think that much better design is to not deal with all these complexities with line breaks in different operating systems, but to use this print writer, which allows you to call println command I think in following way. So, any questions or comments on this exercise? About unused variables, actually, to get rid of warnings, if we decided that we don't need them, remove them. In high quality projects, you shouldn't have even warnings in your code. Any other questions or comments?